Guys, we are talking about linear and nonlinear systems of equations and what the solutions might be for a system of equations. We've seen this in Algebra 2, we've seen it in Algebra 1. We are solving for a solution, an ordered pair that satisfies each equation. So let's say that we have two functions and they are both linear and they cross this point if they were on a xy axis. This point would be the solution. Let's say that we have two lines that are parallel. They will never cross, therefore there will be no solution. Just a review. You guys probably already know this. If you have, let's say, a parabola, quadratic, and a linear, and you can see they intersect at 2 points, we can have multiple solutions. Maybe you'll have a parabola and the line, linear function, will only touch it at 1 point. That will be only one solution. And then maybe you'll have multiple parabolas. You'll have multiple solutions sometimes. Maybe you'll have a parabola only having one solution touching. Maybe you'll have two parabolas that don't intersect. No solutions. So that's what we're trying to figure out with these following steps. What you do is solve one equation for one variable, or you can substitute the expression from step 1 into the other equation to get one variable to work with. You can solve for the single variable. You can resubstitute that solution into the expression from step 1 to find the other variable value. So let's give an example of this. Let's say we have x plus y equals 4 and x minus y equals 2. You might be able to figure out what those numbers are, but if we were working with tougher numbers, this is what we would do. First thing is you want to solve this function for x or y. It really doesn't matter. I'm going to solve for x. So solve this for x and I get x equals 4 minus y. Then what you can do is you can take what x equals, this whole thing, and plug it into the other equation. So you're going to have, in place of the x, you'll have the 4 minus y, and then you have minus y right here equals 2. Combine like terms, you'll have 4 minus 2y equals 2. Subtract 4 from both sides, negative 2 equals negative 2y. Divide by negative 2, you get y equals 1. Now, if y equals 1, you can plug this 1 back into the equation that solved for x. So x equals 4 minus 1. X equals 3. If you have an x value of 3, y value of 1, your ordered pair would be 3, 1. Let's do a word problem. Okay, so a manager of an apartment building needs to buy 45 air conditioners, one for each apartment. She is planning to spend $6,000 on air conditioners. There are two models available, one at $110 each and the other at $160 each. How many of each should she buy to spend a total of $6,000? Now, there's two types. We're going to call the first type X, and the second type Y. Total number of X and Y of each type you're going to add up. It has to be 45 air conditioners. Now, that would be the first function, just talking about the number of air conditioners. The other function is going to be talking about money. We know that the first one costs $110 each. So I'm going to put that price on there. So $110 times however many we have, plus the other type is $160. $160 times the other number of other type. Total, that has to equal $6,000. Using the method that we just learned on the last slide, what I'm going to do is I'm going to solve this top equation for x or y. Let's solve it for x. So if I do it, I'll get x is equal to 45 minus y. When we have this for x, plug it into the other equation. So it'll be 110 times the 45 minus y plus 160 times y equals 6,000. Distribute 110 times 45, and we will get 4950. 110 times the negative y is negative 110y plus 160 y equals 6,000. Now I'm going to combine like terms. Negative 10y plus 160y, that turns into 50y, positive 50y, and you have 4950. Adding to that to make $6,000. From there, subtract 4950 from both sides. You'll still have the 50y, and then divide by 50. You get 21. So y would be the number of the type that cost $160. We say that x is equal to 45 minus y. So we can take 45 minus our 21, and you get 24. So 21 of the type that costed $160, and 24 of the type that costed $110. Nonlinear systems of equations. So one or both of the equations are nonlinear. We're going to be working with quadratics now. First thing I want to do is solve one of these equations by getting one of the variables by itself. Now, I see that 2 is attached to the x, so if I move the y first, I'll have to divide by 2. I think it's easier to move the 2x over first, so you get negative, hang on a second, negative y equals negative 2x minus 1. I move this negative 1 over. Then what you can do is divide by this negative in front of the y, and you get y equals positive 2x plus 1. From there, you can plug this into the y for this equation. So that equation is 3x squared plus 4x minus what y was, which is 2x plus 1. And that equals 7. Now let's simplify this. So the negative applies to the 2x, and it also applies to the 1. So we should have 3x squared plus 4x minus 2x minus 1 equals 7. Combine like terms. 3x squared plus 2x minus 1 equals 7. But what I should have also done is move the 7 over to the other side because we have a quadratic. We want it equal to 0. So I'm going to back up a step, subtract 7 from both sides. And I get negative 8 equals 0. From there we can factor. You say, okay, 3 times negative 8 is negative 24. And I want to find two numbers that multiply to be negative 24 and add to be positive 2. Those numbers would be positive 6 and negative 4. So I break the 2x into positive 6x and negative 4x. Bring down the 3x squared. Bring down the negative 8. Group the first two, factor out what you can. Group the second two, factor out what you can. We can factor out 3x from the first two, x plus 2. And then from the second two, you can factor out negative 4, x plus 2. What we get then is the two factors, 3x minus 4 times x plus 2. Solve both of those factors for 0. You will get x equals 4/3 and x equals negative 2. So we get two answers for our x value. Now what we do to solve for y, we already solved for y using this equation. All we have to do is plug in x into the 2x plus 1. So y is going to be equal to 2. Let's use 4/3 as our x plus 1. You get y equals 11/3. So when we plug in 4/3, we get 11/3. So our point would be 4/3, comma 11/3. And then we have to plug in the negative 2. So y equals 2 times the negative 2 plus 1. And you get negative 3. Plug in negative 2. You get negative 3. That would be the other point that satisfies the order, or satisfies the solution. Next we have another one. This one might be a little bit easier. You can see right up here, the top equation, we can solve for x right away. Move the negative 2y to the other side. You get x equals positive 2y. And we can plug this in for x into the next equation. So we'll have 3 times 2y minus y squared equals 0, which equals 6y minus y squared equals 0. From here, can we factor this? Yeah, we can. We can factor y out of both. So you factor out y, you get 6 minus y. Set each factor equal to 0, you get y equals 0. Set this factor equal to 0, you get y. Hang on a second, let me back up. Y equals 0. Set this factor equal to 0, and you get y equals 6. Now, if we know x equals 2 times y, and you plug in 0 as our y first, you get an x value of 0. So the first point, using x value of 0, y value of 0, that's the first solution. Then, if we use the same equation to solve for x, if we have y as 6, x equals 2 times 6. So the point would be 12, 6. Here's another one where it's easier to solve for x or for y first. I see that if I move this negative x over to the other side, then it's going to become positive and we have y by itself. And then we can plug that into the other equation. So I'm going to rewrite this top equation as y equals positive x plus 4. Use this value of x to plug in right there. So I have x squared plus, in place of y, I have x plus 4. Now it's quadratic. I want to set it equal to 0. So I'm going to subtract 3 from both sides. And I look at that. Can I factor it? That's probably 1. Add to be 1. No. Can I do quadratic formula? So let's use -1 plus or minus the square root of 1 squared minus 4 times 1 times 1 all over 2 times 1. If we realize that our a value is 1, our b value is 1, and our c value is 1, plugging into this equation. So I'll have -1 plus or minus the square root of 1 squared is 1 minus 4 times 1 times 1. So that would be -3. Oops, can't have a square root of a negative. Right there, that tells you there is no solution. Alright guys, good luck. Do your homework. And I'll be back tomorrow.